The James Webb Telescope recently made a discovery that totally shocked scientists. This find has got everyone asking, could there be life on other planets? The telescope was focusing on Proxima Centauri b, the closest star to Earth, when it spotted something strange. It was giving off unusually bright lights, almost like the glow of city lights. But what could be causing these lights on Proxima Centauri b? Could this be a sign that life exists beyond Earth? City lights in space. People have been wondering about life in the universe for ages. Scientists have searched for any kind of proof for years. We've always been fascinated by the idea that we might not be alone. The thought of finding signs of life outside our solar system once seemed like science fiction, but now it's getting closer to reality. This discovery has everyone excited and curious to know more. The idea that there might be living beings out there is thrilling, and any evidence suggesting it has been welcomed with open arms. What makes this even more incredible is how unexpected it was. The James Webb team wasn't planning on discovering city lights in space, especially not from a star so far away. This breakthrough is a huge deal because it's one of the first solid signs that life could exist elsewhere. For years, scientists have been waiting for something like this, a tangible clue that life might be out there. Now, we seem closer than ever to understanding whether we're alone in the universe, or if there's more out there. If it turns out that these lights are coming from an intelligent civilization, it would mean that societies in space could be far different from anything we've ever known. The idea that these city lights have been shining for who knows how long, waiting for the right technology to spot them, is almost unbelievable. When NASA engineers saw these lights from 7 trillion miles away, they couldn't help but wonder, how long have they been there? How long have they gone unnoticed? It really makes you think about the vastness of space and how much we've yet to discover. David Kipping, a scientist at Columbia University, explained that Proxima Centauri b is difficult to understand, especially with these strange city-like lights. The heating patterns on this planet don't match those on other known worlds, which only adds to the mystery. It's unlike anything we've seen before. If these lights are indeed from an advanced civilization, it would challenge everything we thought we knew about planets and life beyond Earth. Most rocky planets take in sunlight and release infrared energy, but Proxima Centauri b is different. Its infrared signature doesn't match what scientists expect from a planet orbiting its star. That's where the James Webb Space Telescope came in. It's the perfect tool to study a strange planet like this. Equipped to capture infrared light, Webb picked up Proxima b's unique heat signature, which could reveal much about its atmosphere. Infrared bands are one of Webb's specialties. It can detect heat invisible to the human eye, especially the temperatures of distant planets. This is a game-changer for studying worlds too far to visit. Proxima b, located about 4.2 light-years away, is an ideal target. By studying its heat signature, scientists can learn about its atmosphere, what it's made of, how thick it is, and whether it could support life. Proxima b sits in its star's habitable zone, meaning it could have liquid water, a key ingredient for life. Researchers are especially curious if it can sustain life, hoping infrared data will help them find out. If Proxima b's atmosphere could support life, it would be a major step forward in our search for alien worlds. Webb's imaging could also hint if humans or other life forms might one day visit or live there. Most space cameras struggle to detect faint light across vast distances, but Webb can see even the tiniest glimmers. That makes it perfect for investigating city light reports on Proxima b's night side. If those mysterious lights are real, the James Webb Space Telescope has a chance of detecting them, provided they fall within a specific frequency range that Webb's instruments are sensitive to. This range would need to be incredibly faint, roughly 1,000 times dimmer than the light our own sun gives off. Such a signal would be exceptionally subtle, hiding in the noise of the cosmos, yet well within Webb's advanced detection capabilities if it truly exists. What makes the situation particularly fascinating is that Proxima b is no ordinary exoplanet. Both its surface and the star it orbits, Proxima Centauri, create unusual and potentially revealing conditions. The star itself is smaller, cooler, and redder than our sun, emitting most of its energy in the infrared spectrum rather than the visible light we're used to. This means that any potential technology or even natural geological features on the planet would be adapted to work with a very different kind of starlight. On Proxima B's day side, scientists speculate there could be structures, possibly similar to massive solar collectors, that absorb this incoming stellar energy. These collectors, whether artificial or naturally occurring, could also reflect light back into space in ways that would be visible as strange glimmers or patterns. Such reflections would not only stand out against the relatively dim glow of the star, but also provide tantalizing evidence for further investigation. Even if the cause turned out to be entirely natural, the implications for planetary science would still be enormous, since they would reveal a new type of reflective surface chemistry or geology never before observed on an alien world. Another intriguing aspect is the planet's rotation and illumination pattern. Like Earth, Proxima b experiences day and night cycles, although the details of these cycles depend on whether the planet is tidally locked to its star or not. If tidally locked, one side would face the star permanently, basking in constant daylight, while the other would be plunged into eternal night. If not tidally locked, the rotation would bring alternating periods of light and darkness, more like what we experience on Earth. Either way, the transition between the warm day side and the cooler night side becomes an important factor in studying the planet's environment. During the day, the star's energy would heat the surface, raising temperatures significantly. At night, without the constant stellar input, the surface would begin to cool. This heating and cooling cycle, and more importantly the rate at which it happens, could tell scientists a great deal about the planet's atmospheric composition or lack thereof. If Proxima b has no atmosphere, the temperature differences between day and night would be extreme. The day side could become blisteringly hot, potentially hot enough to melt certain materials, while the night side could plummet to temperatures far below freezing. This kind of environment would make the planet hostile to life as we know it, and also limit the types of materials or structures that could survive there for long. However, if the planet does possess an atmosphere, even a thin one, it could act as a blanket, trapping heat and redistributing it between the two hemispheres. In this case, the difference between day and night temperatures would be much smaller. An atmosphere could also mean weather patterns, winds, and perhaps even clouds, each of which would leave distinctive signatures in the light and heat coming from the planet. Detecting these differences is not only possible but is one of the main ways astronomers currently study distant worlds. Measuring the exact temperature contrast between the illuminated and dark sides of Proxima b is therefore a critical step. The James Webb Space Telescope can do this by carefully monitoring the planet as it orbits its star, watching how the combined light from the system changes over time. Subtle variations in brightness and infrared heat can be analyzed to produce temperature maps, revealing whether the planet has the kind of atmosphere that could support complex processes or even life. If Webb's measurements show a large, sharp contrast in temperatures, it would strongly suggest the planet is bare and airless, with conditions more like Mercury or the Moon. But if the difference is smaller and more gradual, it would point toward the presence of an atmosphere capable of moderating the planet's climate. This, in turn, would open the door to questions about its composition, whether it is rich in carbon dioxide, nitrogen, water vapor, or some exotic gas chemistry unlike anything found on Earth. Every piece of data Webb collects brings scientists closer to understanding Proxima b's true nature. Whether those faint lights are the product of advanced technology, unusual geology, or simply a quirk of reflected starlight, their detection would mark a milestone in exoplanet research. And beyond the immediate question of the lights themselves, the careful study of Proxima b's day-night temperature balance could unlock deeper insights, not just about this one nearby world, but about the countless others waiting silently in the darkness between the stars. Webb can quickly analyze heat emissions from the planet, giving scientists crucial data about what kind of atmosphere Proxima b might have. The telescope's observations have now sparked one of the most exciting debates in modern astronomy. While observing Proxima b, scientists detected unusually bright lights resembling city lights, raising the possibility of an advanced civilization. If confirmed, this discovery could change our understanding of the universe and our place in it. Since Proxima b is in its star's habitable zone, the possibility of liquid water exists. Researchers are not just focused on temperature measurements or reflected light, they are also studying unusual light patterns that could, in theory, be artificial in origin. These could be signals produced by advanced technology, such as structured arrays of lights, vast energy collectors, or other engineered systems that emit or reflect light in distinctive, non-random ways. If such patterns are detected, scientists will examine their frequency, intensity, and repetition to determine whether they might arise from natural processes or if they suggest something far more extraordinary. If Proxima b has an atmosphere, the next step will be to analyze its composition in detail. This is where the James Webb Space Telescope's powerful spectroscopic instruments come into play. By observing starlight as it passes through the planet's atmosphere, Webb can identify the unique fingerprints of different gases. Among the most critical are oxygen, methane, and water vapor molecules that, when found together in significant quantities, are considered strong biosignatures. On Earth, this particular combination is sustained largely by biological activity, meaning that detecting it elsewhere could point toward the presence of life. Finding such elements on Proxima b or any exoplanet would be nothing short of groundbreaking. It would provide one of the most compelling pieces of evidence yet for the existence of life beyond our own planet. While not an absolute guarantee of intelligent life, the detection of these gases in the right balance would ignite worldwide scientific and public interest. It would raise profound questions about our place in the universe and the possibility that life might be common, rather than rare. The search does not end with a single planet. Scientists are now eager to continue their exploration, using Webb not only to study Proxima b but also to survey other worlds within their star's habitable zones, the regions where temperatures could allow liquid water to exist. By systematically mapping these planets, astronomers hope to build a clearer picture of how common potentially life-supporting environments really are. Each observation brings humanity one step closer to answering a question that has echoed for centuries. Are we alone? With the technology now available, the answer may finally be within reach, and the universe might be far more alive than we ever imagined.